7 campus bikes. So for this problem, we are getting a graph. So inside the graph, it means the coordinate of the bikes and the coordinate of the workers. So for example, inside the workers array, we have the coordinates of 0, 0. So this means at this place there's going to be a worker. And this 2, 1, it means at the place of 2, 1, we're going to have another worker. Yeah. So this is going to be the worker 0. So this is the index 0. It's going to be the worker 0. And index 1 going to be the worker 1. And similarly for the bikes. So for the bikes 0, it's going to be a 1, 2. And bikes 1 going to be a 3, 3. Yeah. So what are we going to return? Yeah, we're going to return some distance. So it is the Manhattan distance. So we need to know how to calculate the Manhattan distance. Basically, it's going to be the absolute value of x1 minus x2 and y1 minus y2. So basically, this is the calculation of Manhattan distance. Yeah. Now what we're going to return? We're going to return an answer array. So the length is going to be n. Yeah. So where answer I is the index of the bikes that is ith worker is assigned to. Yeah. So the length of the answers array gonna be the length of the workers. We should know that. Yeah, because according to the return, so for each of the index, it means the ith worker. So for example, index 0, it means it is the 0 worker or 1, 2, 3, 4, etc. And then for each of the index, so the index means the workers, and then we're gonna choose a bike. Yeah. So for the first example, index 0 gonna choose a bike 1, and index 1 gonna choose a bike 0. Yeah. So this is the meaning of the question, and we also need to know that yeah. So we should also know that if there are multiple answers like the worker I and bike J pairs with the same shortest Manhattan distance, what are we gonna do? We're gonna choose the pair with the smallest worker index. Yeah, so this means we're gonna always choose the smallest worker index. And if there are multiple answers, we're gonna choose the pair with the smallest bike index. So this means we're gonna first choose the worker index, smallest worker index, and then we're gonna choose the smallest bike index. Yeah. So this means for this problem, we might use something called sorting. So if we know the distance, if we know all the distance pairs, so for this example, as there are at most 1,000 bikes and 1,000 workers, so this means we can use O(n) squared to solve the problem. Yeah. And our worker and bike locations are unique, so this is also okay. We don't need to turn that into a set because all the positions are unique. Yeah. But our idea is that we're gonna prepare a tuple, and we're gonna put all those tuples inside an array. So the first place is gonna be a distance. So the distance is gonna be the Manhattan distance. So for example, we're gonna choose the first worker. This is gonna be the first worker, right? And then this worker gonna choose all the different distances. So this worker 0 to bike 0, what is the distance? To bike 1, what is the distance? Yeah. So first one, it's gonna be a distance, and then it's gonna have a position of I and J. So I means the ith worker, and J means the J's bikes. So we're gonna enumerate all the different cases. So at most, that's gonna be 10 to the power of 6 different cases. And after that, we're gonna sort it. So after sorting, we're gonna get the closest, smallest distance first. Yeah. So this means after sorting, we can loop through the array one by one to check the distance. So first of all, we're gonna choose this one. Yeah. But they're gonna be duplicate. What if we already choose this ith worker? So for example, this is the 0 worker we have already chosen. But for the next time, there's another 0 worker. Can we choose that? We cannot. Yeah. So this means we need to use a set to avoid the duplicated distances. So if this distance is chosen, if this is a 0 and 1, I is 0 and J is 1. So for the next time, definitely we cannot choose this is 0 and 1. We have to choose others. We have to choose like 1 and 0. Yeah, we cannot choose 0 and we cannot choose 1 as well. So this means definitely we cannot choose them because the 0 and bikes, it has already becomes a pair. Definitely we cannot choose any one of the workers or any one of the bikes. So this means we're going to use a set to avoid all the duplicate cases. Yeah. Now I think it's enough for us to start coding. So let's just prepare a result array, and inside of the result array it's going to be a tuple of distance, workers, position, worker index, and the bikes index. Yeah. Now let's just check one by one. So for I, x1, y1, yeah, enumerate the workers, and then we're gonna choose j, x2, y2. This is gonna be the bikes position in enumerated bikes. Yeah. So we want to put it inside of this result array, and it's going to be a tuple. So this tuple is going to be the absolute distance of x1 minus x2. So this is going to be the Manhattan distance, and y1 minus y2. Yeah. And after that, we're going to have the position of the worker and the bikes. Yeah. Now we're going to prepare an answer array. It's going to be 0 times the length of the workers, because the index is going to be the workers. And then we're going to use the index to choose the bike. So yeah, we have to prepare it's going to be the length of the workers. This is according to the question. We have to understand this on return. Yeah. So we're going to return an answer array of n. So where answer I is the index of the bike that the ith worker is assigned to. So we're going to prepare all the ith workers that are going to be the index, and then we're going to choose the bike. And the bike is also index. Yeah, so we have to understand this one, because this is a misunderstanding, because everything is represented by index. But actually, that the ith worker is assigned to. It means we're going to choose all the workers. So that means for the answer array, it's going to be the length of the workers. So finally, we're going to return the answer array. Yeah. As I said before, we need to use some set to avoid the duplicate. So we're going to prepare workers set and bikes set. So it's going to be empty set from the beginning. Now, what are we going to do? We're going to just loop through one by one. Yeah. So we're going to loop through the distance x and y inside the result array. So we want to check if x not inside the workers set and y not inside the bikes set. So this means definitely we can choose this x and y. But how can we choose that? We can prepare our answer array. So the x is going to be the index of the workers, and y is going to be the index of the bikes. Yeah. And then if it is not inside, we have to put it inside, right? So the workers set going to add this worker, and the bikes set going to add this bike. Yeah. So in this way, actually, according to this way, we can find all the unique pairs, because we're going to use this set to avoid all the duplicates. So this means if this pair, so for example 0, yeah, so for example the zeroth worker, first of all we're going to choose the zeroth worker, and we're going to choose some bike. Yeah, so the workers 1 gonna grab a bike 0. So this is the 0th worker. Gonna choose bike bike 1, and the worker 1 gonna choose bike. Yeah, I think there must be. So this is a bike 1, and this is a bike 0. Yeah, so this is a worker 0, and this is a worker 1. Yeah, let me just submit it first to check. It didn't work. It should be 0 1 instead of a 1 0. Yeah, it should be 1 0 instead of a 0 1. So my return is 0 1. Yeah, let me just check because I think I didn't, I forgot to sort the result array. So this result array actually should be sorted. So after sorting, let me just submit it. Yeah, now as you can see, it works. Now let me just submit it to check if it can pass. Yeah, as you can see, it passed for all testing cases, and I think the speed is okay. It is close to 1 second. Yeah. So now let's just use the first example to analyze, because the time complexity is n log n, n squared log n. This n gonna be and 10 to the power of 3, so it n squared gonna be 10 to the power of 6. Yeah. So it is a 10 to the power of 6 log 10 to the power of 6. So basically this is going to be like 10 to the power of 7 for the final time complexity, so that should be okay. Yeah, so this means the worker 1 gonna grab bike 0 as they are closest without ties. So where is worker 1? So this is worker 1. Yeah, the worker 1 will grab the bike 0 because this is closer, right? Yeah, and the worker 0 gonna grab the bike 1. Yeah, so the worker 0 is assigned to bike 1. Yeah, so although it seems a little bit confusing, normally for this worker 0, we want to choose something maybe average. So what about worker 0 choose bike 0 and worker 1 choose bike 1? So the distance is 3 here, the distance is 3 here. But this is not the meaning of the problem. Yeah. So the meaning of the question is asked is that we can always choose the worker 0 first. We're gonna always start with the bike first. Yeah. So for this bike, we're gonna assign a worker. So this worker definitely gonna be worker 1. Yeah. And for the next bike, it is bike 1. We're gonna assign a next worker. It's gonna be worker 0. Yeah. So this is a what we are asked. Yeah, because it's not like we are choosing a worker and then from this worker we're gonna choose a bike. Yeah, actually it is we're gonna get a bike first, and then we're gonna use this bike to assign a worker. Yeah, so it is not always with 2 workers and 2 bikes. It can be even more bikes. Yeah, I think that's all about it. Thank you for watching. See you next time.